Let's go back in time to September 3rd, 1928. Scientist Alexander Fleming had just returned from his vacation to his job as Professor of Bacteriology at St. Mary's Hospital in London. While he was sorting through his petri dishes containing bacterial colonies, he noticed something unusual. One of the petri dishes had bacteria growing all over except for an area around a blob of mold. He quickly realized that the mold was releasing something that was killing off the bacteria around it. Fleming and his co-workers decided to extract that bacteria-killing juice released from the mold, later identified as Penicillium notatum, and thus the first antibiotic, penicillin, was discovered. Hey everyone, welcome to Scientastica. Today we're going to talk about antibiotics. Since their first mass production in the 1940s, antibiotics have been widely used to treat infections. Dying from bacterial infections from a paper cut is a thing of the past. However, the widespread use of antibiotics has led to a bigger problem: the rise of antibiotic-resistant bacteria, or superbugs. Some bacteria are inherently sensitive to antibiotics, while others are inherently resistant. When we use antibiotics, bacteria respond by displacing the sensitive bacteria with the more resistant ones. These antibiotic-resistant pathogens usually first emerge in environments like hospitals, where naturally available antibiotic levels are higher. Additionally, with repeated use of antibiotics, bacteria that are initially sensitive to antibiotics begin to acquire antibiotic-resistant genes in their genome. This new genetic element acquisition process is much faster in bacteria due to their short generation time, meaning bacteria can divide to produce new antibiotic-resistant bacteria in a matter of hours. Our bodies are full of microorganisms. When we take an antibiotic, the only bacteria that remain alive are the drug-resistant ones. This means if you have taken antibiotics in the past, you may harbor a few strains of antibiotic-resistant superbugs. But how has the superbug crisis reached such a threatening level? One of the reasons is overuse of antibiotics. Even Alexander Fleming, the inventor of penicillin, foresaw this coming. In his Nobel Prize acceptance speech, Fleming mentioned that increased demands from people for antibiotics will result in antibiotic abuse. The unique thing about bacteria is that they can transfer their genetic material to non-relatives via mobile genetic elements like plasmids. This makes it way easier for bacteria that survive antibiotic to transfer antibiotic-resistant genes to other bacteria. Despite this well-known fact, antibiotic keeps being overused across the world. A survey from IMS Health Midas database shows that in 2010, 22 doses of antibiotics were prescribed per person in the United States. In some states, the number of courses of antibiotic treatments exceeded the population of the states, meaning more than one treatment series was prescribed per person per year. This situation is even worse in many other third world countries, where antibiotics are not regulated and even prescribed over the counter. Another reason behind the rise of superbugs is the use of wrong types of antibiotics. Studies have shown that 30 to 50% of the time for an antibiotic therapy, either the treatment indication, choice of antibiotics, or duration of treatment was incorrect. Additionally, about 30 to 60% of the antibiotics prescribed in the intensive care unit patients are either inappropriate or completely unnecessary. Inappropriate and suboptimal use of antibiotics can actually increase the genetic alterations that favor antibiotic resistance in bacteria. Third reason behind the rise of superbugs is the use of antibiotic supplements in agriculture and livestock. Around 80% of the antibiotics sold in the United States are used in animals to promote growth and prevent infection. Overuse of antibiotics in food-producing animals kills antibiotic-sensitive bacteria and allows resistant bacteria to thrive. When we consume these animal products, these resistant bacteria get transferred to us and cause infections that are harder to treat with antibiotics. But humans are not the only ones being affected. Antibiotic-fed animals can also harm the environment. The antibiotic-containing stools and urines from these animals, when used as fertilizer, together with antibiotics present in pesticides, can also massively damage the soil microbiome. And finally, most of the antibiotics that are commercially produced work the same way. They block some essential functions of the bacteria. Antibiotics can block bacterial metabolism, disrupt cell membrane, or inhibit protein, DNA, RNA, and cell wall synthesis. Thus, most new antibiotics don't come up with new ways to kill bacteria. They just improve on the already existing methods. As a result, if a bacteria develops immunity to a single way of killing, it usually nullifies the use of a group of antibiotics that uses that particular pathway to kill bacteria, resulting in the rise of a multi-drug resistance superbug that is very difficult to treat. So what can we do to deal with these superbugs? An obvious step is to stop unnecessarily prescribing antibiotics and ensure a proper diagnosis to determine the most effective antibiotic type. But this is easier said than done. Government-level regulation is necessary to ensure fair use of antibiotics. At least, we as individuals can take steps and ask our doctors whether a prescription for an antibiotic is appropriate and necessary. Additionally, scientists are researching promising new alternatives to antibiotics. One such alternative therapy is use of bacteriophages, which are viruses that kill bacteria. Bacteriophages kill bacteria by taking over the control of essential survival mechanism of bacteria. Recently, bacteriophages were used to treat a few patients with life-threatening infections of the skin, liver, and lung caused by antibiotic-resistant bacteria. So, to end today's video, to deal with emergence of antibiotic-resistant superbugs, the governments need to regulate abuse of antibiotics in both humans and agriculture. Industries need to invest more in the development of antibiotics that kill bacteria in novel ways and research alternative ways to treat antibiotic-resistant bacteria. At a personal level, we should be mindful of what medication we take and always ask our doctors what medications we are prescribed and ensure that the antibiotic we are being prescribed is necessary and appropriate. Thanks so much for watching. Give the video a thumbs up if you enjoyed it. Until next time, I'm Reza and this is Scientastica.
By the sea, anywhere we wish to be. When we're loved, we're happy and free. Come together.